All right, so today, listen up. All iPads can be put down. We don't need to be working on class K right now. So we can put all our iPads down, or take notes on it, and be on your notes. We have like a decent amount of stuff. Plenty of time to get a full lesson in. All right, factoring special products. So we've worked on factoring the last couple of days, right? That's when we have something that's in a form like this, right? And then we write it in a form where we have some number here. Let's just call it X. Nope, that's not going to work. Let's just call it W, if I could write, and some number here. Let's just call it Y. Okay? Yeah, they're not supposed to. That's okay. There's not a lot to go over today. All right? So that's what we've worked on so far. Now, there are a couple of cases that we would call special cases or special products. One of them is that
excuse me, could I please have Joseph Janicki in the office for just a moment?
Of course.
Thank you.
There you go. One of our special cases would be when we don't have this middle value right here, where we don't have a b value. So you would see it where it's just like a number with x plus c.
No.
So that's one of the things, if you look at the class kick yet, that's one of the things we'll be looking at today. We're skipping our warm-up. Learning targets, students will be able to factor differences of two squares. So the difference of squares is just one of the names we use for a special case. And students will be able to factor perfect square trinomials. That's just another special case. We have a new term or two. We have a couple examples. And then the practice, because we're using class kick, which is awesome.
Let me show you how you do an exclamation.
All right. First, new idea. Sorry, I didn't have time to like retype them and put like the cool fonts. I just had straight. You guys good? Straight screenshot from the book. So kind of lame, but this is what we got right now.
Ooh. Dude, everyone's
Everyone needs to take a deep breath. Relax. We've got a quick lesson and a worksheet. It's all good. And a class kick, which I know is exciting, so we're a little restless. Easy. So, our first key idea or new idea is the difference of two squares. Okay? Difference of two squares. So this stuff over here is fine to write down. There's nothing wrong with that. I think that is a little bit difficult to understand, but it's okay to jot down. This example on the right side is what I want to talk about for a minute. So I'll give you like 30 seconds to get that written down, and then we can talk about it.
Why does algebra exist?
Yeah, it's really not good.
Are you okay?
The kids that want to do algebra should do algebra. The kids that don't.
All right, let's look at this example.
Exactly.
This example. Now, first, the title, difference of two squares. Difference just means what? Multiply? No, subtract. 2 is not 1, not 3, but 2, right? So the difference of the subtraction of two squares. Remember, something that's squared is to the second power. All right, so difference of two squares. Scary words put together, but we know all of them, so we can do it. in this example, we have x squared minus 9. Now notice the first thing that they do to make it a little easier to write is they write it as 2 squares. So we know that 9 is a perfect square, so we can just write it as 3 squares. Okay, so that's the first thing that we want to do if we think that we have a difference of 2 squares. Rewrite it so both numbers are 2 some power. Then we can write it as x plus 3, x minus 3. X plus 3, x minus 3. So, I mean, if we think about FOILing that out, there would be our x squared. Here we would have minus 3x plus 3x, and then we would get our minus 9 at the end. Since we go plus and minus in the parentheses, our middle terms cancel out. So this should not be very shocking, right? We've subtracted, added those middle terms. I just don't think they've canceled out yet. Nothing. We can do this. So I will look at a couple examples here. First one, x squared minus, how can we rewrite 25? 5 times 5, so 5 squared. So if I'm factoring it all the way, I got both of them squared, x plus 5, x minus 5. Done. How can I rewrite 64 so that it's 2 numbers squared? What would it be? What times 1 gives me 64? 8 times 8. 8 squared minus y squared. 8 plus y. 8 minus y. So, yep. This would be your answer right here. Now what about letter C? What are they looking for in letter C? What do you think?
Minus 2c squared.
Minus says what? We can rewrite this 4, right? So we would have, whoops.
Don't irritate me.
Minus 1. Are we following so far? Rewriting 4, so it's 2 squared. Or so that it is 2 squared. That does look kind of goofy, doesn't it?
Come on, oh. You.
And these are the same, correct? Based on our exponent rules that we talked about 2 chapters ago? Yeah, sure. We'll just say yes because I asked. Now, does it make a difference if we write 1 or 1 squared? Is there any difference there at all? Any difference? No, 0 difference. So what they're looking for in this one, and this is the most complex example that we'll see, is that you could write it 2z minus 1 squared. So that's what they would be looking for on letter C. Again, most of them will look like this, or like this. Not supposed to be anything too big. Oh, okay. So this is where you would open your class K, and I believe this is the first 2 slides. How? What?
Do we have to write like the step in between?
Nope, you do not. I mean, for number like 3 and number 4, that might be a little bit helpful. But for number 1 and 2, you can go straight to the problem. Work on these for like, we'll give like a minute on these, and then I have one more idea, a couple more examples, and then a couple more practice. So we'll just take a quick break. Give you a second to work on it. Yeah.
wasn't my fault.
It's f that has 6. Oh yeah, and make sure you use your real name. It's not going to look at your real name. Actually know who you are. That works. That works. Well, I guess that works too.
Alright. 49.
Shut up.
Mr. Laman. Mr. Laman.
Wait, do you square it or you just that?
I want to know what it feels like.
Cube it.
See, look, it's up there. Look, you guys go look together.
No. Don't show
Whoa.
Oh, dang
Why
it.
not?
Oh, good job, Parker.
Yeah.
How do I give you a star?
He doesn't deserve a star.
You're right, he deserves a ladybug.
Yeah.
You stay here, part of the
You press add new sticker.
I raise my hand, I'm so
What's this riz? It means like you raise your hand for him to go answer your question. Hey, check my
Except
question.
this one, you want to put 10 minus that. That's all right. All right, about 10 more seconds.
Just wait, let's do that.
Oh yeah.
Well, he'll talk to work on LPN. I just want to introduce you to it and then.
What?
I raised my hand on both of them.
Then you can bring it down.
I know. It's all good. All right, we're going to look at another idea. And this one is a little bit more difficult. Of course it is. We have to start with B. So, please don't touch out. Here we go. Perfect square trinomial pattern. Okay. Perfect square. Well, perfect square is like 9 or 16 or 4 or 25. Perfect squares. Okay? Good. Perfect square. Trinomial, remember, just means 3 terms. And pattern would be like, I don't have anything to relate pattern to. What? Oh, it fell again. Second time today.
Maggie did it.
Maggie.
Maggie.
Sorry.
It's okay. Don't let it happen again.
So again, in this case, the algebra, a little bit tricky, the way that they talk about it. The example, a little bit tricky, but not terrible.
Mr. Layman, it's the same thing twice.
Is it the same thing twice? This example here is with addition. This one is with subtraction. So not the same exact thing.
What's different about them?
They're pretty much the same, except this answer has addition, this answer has subtraction. Not a huge difference.
What one do you want us to write down?
I probably would write down the example. Yeah. The algebra part of it is fine, but the example is probably more helpful.
She literally wrote something.
I did not.
We'll go like 30 more seconds to get that example down.
Write down
Hey, you guys have been very chatty over here. Right? That doesn't surprise me. You've been very chatty over here. post slides. I can do that once I get the worksheet out there.
I'm just gonna drop
Okay.
cake.
Are you drawing me a picture, partner?
What?
Are you drawing me a picture?
Yeah.
The cat.
Alright, so let's look at this example. In a little bit, like, let's look at it line by line. So otherwise it'll be overwhelming. It's really two different examples, okay? This first one up here, we have all plus signs in the middle. Now what we're trying to do when we have the perfect square with this perfect square trinomial pattern is we're trying to first write our C value as a square, just like we did earlier. You can see there it is 3 squared. And then we are also trying to rewrite our B value, the 6, as 2, it'll always be 2 times that perfect square. So in this case it is 3. Now, don't ask me how it works, because it's magic, so I can't tell you. But if we can write it in this form, where we have x squared plus 2 times that perfect square, then we can rewrite it as x plus, again, that perfect square, squared. Got it?
Sure.
A lot of square, perfect square, and squared in that explanation. Now, the second example has a minus and then a plus sign. So we go through the same process. We try to write our C value as perfect square. We try to rewrite our B value so that it's 2 times that perfect square. And now this time, when the magic happens, there's a minus sign in it. Okay, let's look at an example. So let's go with let's go with those steps that we talked about. First thing we want to do is change color. First thing we want to do is look at the C value. How could we rewrite this as a perfect square? 4 squared. Yep. Now we need to write 2 times 4. We can write 2 times 4. I'm not really sure why they, like in our example, they put our variable in the middle of both of them. I'm not really sure why they do that, but they do, so we will. So, and we just need to double check. 2 times 4 would give me 8, so we are all good there. We're just rewriting things, so that means by some magic, we can rewrite it like this.
By some magic.
We can check it if you want to.
No, it's okay.
Do you just want to trust me?
Yes.
Well, I mean, you are the teacher, so.
Well, now this time we have a subtraction sign. We have a negative 18. So we're still going through our same steps. X squared minus 2 times x times something, we don't know yet. Plus, how can we rewrite 81 to be a perfect square? 9 squared. That is 9 times 2 gives me 18.
Sure.
What? What do you mean sure? 9 times 2 gives me 18?
Yeah.
Yes. So now the magic happens, except this time we have a minus sign in the middle. Whoa. Pretty sweet, huh? Super cool. Okay, now you get to finish your practice on class K. If you do not, is anyone not able to get into class K? Like it wouldn't download or whatever? Sweet. All right, then I will start checking problems. Once you think you have them all done, come on up. We've got, it's only one page, but it's spaced out onto 2. Question, Skylar?
Yeah. Mr. Laman.
Yes. Question? Oh, okay. All right, here we go.
Mr. Laman.
Yes.